Hey everyone, my name is Abraham Pena-Talamantes. I'll be talking about contour and surface plots, not only because they correspond to my last names, but also because I feel like you can't speak about the benefits of one without mentioning the other. A lot of the data that we've been working with thus far, a lot of the graphs that we've been doing to this point have been two dimensional and usually involve two variables. And even when we have multiple variables, we tend to go out and do like pair plots or other types of plots that will plot only two variables at a time together so that we can see those relationships, whether that's correlations or different types of relationships. But for the most part, a lot of the regressions, simple regressions that we've been doing, scatter plots, bar plots, histograms that speak to frequencies in the data, all of these things are pretty much always graphed on an x and y axis. But in real life, a lot of the data problems are a lot more complex. If we're trying to figure out the interest rate on a loan, a bank would use a whole bunch of different variables to make that decision, to make that prediction, and to look at historical data to see whether or not a person's going to default on that loan. So those are more of the types of problems that we're going to be dealing with in the work environment at the different organizations and institutions that we're a part of. So these are all multivariate problems, or you can also think about them as multidimensional problems. We not only have an x and a y, but we have a z, or maybe we have an abc and all these other different variables. You're usually still talking about a dependent variable versus all its independent variables, or sometimes maybe you're just looking at multiple independent variables to see kind of they relate to each other. But as we see on the graph samples here, the same points that we have up here can be graphed in a more of a 3D way. And we start seeing that there's a different kind of layout to those, and there's a bit of clustering, which might not have been seen if we had just had the two-dimensional image up top. Dimensionality is really important because speaking to the graphs that we were just looking at in a little bit, and bringing in this iris dataset, you can see that having a two-dimensional graph gives you an idea of maybe where these little clusters lie in these data sets. This is an iris data set that's pretty common in machine learning and Python and a lot of these different other kind of data classes. But once you transpose that into a three-dimensional space, you start realizing how these data points interact. That maybe it's not as simple as we originally thought. In this case, we're looking at these different colors representing different species of irises, of flowers. So we do live in a 3D world, which means that it makes a lot of sense for us to be able to graph and see and understand what that 3D graph represents. Sometimes it's a lot easier to digest that information. And so we might be more willing to kind of push ourselves to see like how many things can we graph in this 3D world. Realistically, that also means that if we're talking about a very robust data set with a whole bunch of different variables, you'll only be able to graph like three at a time. You can graph more dimensions. It doesn't necessarily mean that we're going to understand what they are, because once we move into the fourth dimension, that's a really difficult thing for our brains to understand. So in that case, you're working more with numeric data, or you're using subsets of actual variables. This is kind of where surface and contour plots come in. They both represent multivariate data, specifically three variables. In this particular graph, we have the representation of the function fxy, which is represented by x squared plus y squared minus x times y. And all of this particular equation equals the data point z. And when you graph x, y, and z, you get these particular graphs that you see in the bottom. The surface plots, like the one on the left, provides the relationship between x, y, and z in a 3D view, and it looks like this really cool curve. The contour plots, on the other hand, are two-dimensional representations of the multivariate relationship. In other words, if you were to take a helicopter and go up to the top and look down on the graph, you would have a bird's eye view of the 3D graph on a 2D plane. And the darker colors, as represented in this particular graph, would mean that there's deeper depth to the data, where the lighter colors mean that there is much less depth. And so you kind of have those peaks that we see here and here represented out here and here as the lightest points on the contour plot. So looking at that, you might think, hey, well, surface plots are much better, right? Surface plots provide a full 3D representation of my data, so it's easy to associate the better version of the graph because it looks nicer and maybe it makes more sense. And ultimately, you can kind of give some shape to boring data. And if we look over here, we see the elevation of Mount Bruno, Canada. And again, it looks like a really cool graph. But there's one big major issue. Surface plots hide important data because of their tilt. If I were to present this, I would think, hey, that's really cool. But if I wanted to know the value of a point that's behind this curve or this hill, it would be really difficult for me to figure out what that is. This data point that let's say back here, which is maybe like -1, 5, this data point, moving it up, I don't actually know what that is. If it wasn't for the contour plot that exists below my surface plot, I wouldn't know that it belongs in the yellow part, which means it might be in this yellow part. Again, without this contour plot down here, I would not be able to see all the data points in this surface plot up here. And that's one of the major issues. Contour plots fill in the blanks. So while all these surface plots up here are really cool and nice to see, and we can understand the shape because we understand 3 dimensions, we cannot always see the values of all of the data points associated. Looking at Mount Bruno, what's behind this peak, I don't know. But if I look at this contour plot down here, I can see what's behind the peak because the peak is here. So if I wanted to know what's at 10 meters and 15 meters, oh, it's a dark purple, which means that, the elevation is, I don't know, around 50 feet or whatever. So that just comes to show that sometimes the simpler type of graph or the 2-dimensional graph can provide more information than the 3D graph. That might, upon first inspection, seem like the answer, the way to go. So contour plots ultimately may be better, but of course only in some cases. There's always pros and cons to different charts. Contour plots can be thought of as a bird's eye view of the data. Not all data will result in nice shapes that are easily interpretable with surface plots. And so that might be a place where these things might be very useful for you. So if you need information on a specific data point, a contour plot may be a better fit for this. And we've seen them a lot, and I don't think we've realized that that's what they are. Anytime that there's indicators of depth or indicators of density in a geographical location, we tend to see these contour plots. Things like maps, trails at a park, maybe representations of depth of the ocean in certain parts. A lot of the times we associate them with maps, but that's not to say that they're not really useful for business analytics data. And in this case, in this graph, we have surface temperatures of the United States in 2003. So how do we apply it to business data? Well, we know that these 2 types of graphs will allow us to see the relationships between 3 variables. And we can get more information about this relationship by graphing it. Regressions usually assume a flat plane. So conducting a contour plot may give you more information about the relationship between 2 independent variables and 1 dependent variable. And maybe using a surface plot or a contour plot, you could also see, what is the expected value for 2 independent variables connecting together. Now, contour plots can help see all aspects of the relationship when the surface plot might not make sense. So I'm going to take over to SAS to look at what this kind of looks like. Um, well, first, I guess let me log into this thing. All right, so here I've set up a process flow. It opened up the credit bureau data set that was in our ISOM 835 files that I found, just looking through and see what might work for this. Here we have three variables that are of interest. So a trade line count, so how many credit accounts a person has. The first trade line year, so when was the first account opened, and then we have their FICO score. So the other ones I really don't really care much about, but we can do describe characterized data, and it takes me to the report of what is in the data. Now, you always want to do this because you want to make sure that the type of graph that you're using actually makes sense for the data that you have, and sometimes it doesn't. So you have to think about those assumptions. So in looking at the characterization of the data, the first thing I notice is that my FICO credit scores are very normally distributed, which is great. So we can keep going. I now look at the first year of the trade line, the first trade line year, and I notice that there's this really interesting negative skew here. And so a lot of the data seems to be grouped from like 1960s and onward. And then we have the opposite, a positive skew on the trade line count. And so after about 25, there isn't a lot of data there. Now, I tried doing this and putting it through the graphs, but it was erroring out. And a lot of it was because a lot of the things up here, these data points, didn't have enough information to really produce a good graph. So what I decided to do was open up a query where I decided to filter data out and only look at trade lines of 20 or less, and only of people that had opened them up from 1990 or after. And so that gave me this new shorter data set that I could work with. And in characterizing that data set, I was able to see that the data seemed to make a little bit more sense. So I assumed that maybe if I connected these two, I could get a better understanding of what was going on behind the scenes. So in order to run these graphs, what we have to do is come here to graphs, or you can go to tasks graphs, but it's easier when you're in the data set itself. Click on graph, you can click on surface plot, since the first thing we kind of can see, and I want to select this 3D gradient surface plot with banding so that I can understand the different kind of depths to it, if you will. Then we click on data, so we have the three variables that will go over here. The horizontal is going to be kind of the closest one to you. In this case, depth is going to be your axis that goes away from you, and the vertical one is going to be the one that gives the true depth to the graph. So if you had a mountain, for example, the peak of the mountain, the elevation itself would be on that vertical area. So here what we're going to do is I'm going to take the year and put it in the horizontal. I'm going to take the FICO score, since that's the one I'm kind of sort of interested in looking at or predicting, and putting it in the vertical. And then I'm going to put my count in my depth. So in a way here you can think of x, y, and then my dependent variable. There's other pieces of it here. You can actually have a contour displayed above or below your surface plot, but I don't want to do that because I just want to look at it on its own. And you can mess with the tilt, but again, I'm not going to do that. In terms of axes, I'm going to leave these as defaults. Chart area, I'm going to leave it as defaults. You can make some changes here if you like. Grid data is not something I need to mess with. I'm going to leave the titles as default, but I could uncheck this and write my own title. So I'll run that surface plot, just wait on it and see kind of what comes out of it. All right, so here's a surface plot of our first trade line year with our trade line count with the FICO score on this like up and down here, so on our vertical axis. And while it looks really cool, it's kind of confusing to look at. So if I were to present this to somebody and see, oh, here's the answer we're looking for, it'd be really difficult for them to really understand what is going on. So we know that things that we can see, for example, somebody who, so the trade lines go from like 1990 to 2005. Historically, you would want more trade lines. I would assume that if the trade line year opens up a lot late earlier, then it would you would have more credit history. This is really short credit history. So having longer credit history and having only one or zero in this case trade lines means that you have a really low credit score, which makes sense. Um, and up here, this purple peak, well, I can't really tell what that is. What exactly, where does it belong? But I do know that there's a couple of purple areas that seem to be spread across everywhere else. So it's not as easy to understand where those areas might be. So this might be where it might be better to look at a bird's eye view of my data versus the surface plot. So I can go back to my data that I created, the subset that was filtered out, and I'll create a contour plot instead. I'm gonna fill it out in data. So this is a little bit different than the other one because now we're talking about a 2D graph, not a 3D graph. So what these mean changes a little bit. The horizontal is basically the equivalent of your X. So I'm going to put my year in there. Your vertical is the equivalent of your y-axis, which is the one running up and down. And in this case, because it's a 2D graph, I want to put my trade line count. And the depth is what's going to be colored in my graph, which is my dependent variable. So in this case, I am going to put the FICO score in there. And I'll go ahead and run that. This comes back pretty quickly, but even though it doesn't look as cool, as the other one, mountainous terrain that we had in the other surface plot, this contour plot gives me a lot more information. I can very easily and clearly see who has the lowest scores. I can see that there's a lot of people kind of in the middle of the range with this greenish color, so most of the chart is filled with that. There's people with a lot of brown, which means with the score between like 672 and 706 or so. But of most importance is, well, who are the ones with the highest credit scores? Well, that's this yellowish color. It seems like it's the people here. Now, looking at this first line of opening credit between 1990 and here it says 2002. So we're at 2002. That's a really new account. This is, credit history was built from before. So people that have about a 10-year-ish credit history with about 15 credit accounts seem to be the ones with the highest credit scores. And then there's a combination for everything else. So it's interesting to see, where are those little yellow pieces coming out? And here's an interesting little tiny one. But this particular plot gives me more information than the surface plot for this particular type of data. So as you can see, looking at them side by side, it is pretty clear that while my contour plot is not as fancy looking, it gives me more information that I can actually give to somebody, and it's a little bit easier to understand than trying to figure out maybe what the invisible hidden values behind these peaks might represent. So just to wrap up, so surface and contour plots allow you to display relationships between three variables in one graph. Surface plots will render in a three-dimensional set of planes, while contour plots will map the three-dimensional output onto a two-dimensional graph. Surface plots are useful to identify general shapes in the data, but might hide certain points given the tilt and the rendering. And contour plots allow you to see the values associated with all the points, but it might be difficult to visualize how they might look in 3D if the depth is not as easily defined, which means that if these colors down here were not as different, maybe there were different shades of blue or whatever, it might be a little bit more difficult to figure out where those actual peaks are in. Or if you forgot to put the legend in there and you couldn't see what colors corresponded to what depth, it's very arbitrary to then tell which ones are peaks and which ones are valleys. So with that, I think that this is a pretty interesting kind of set of plots that we can use for the data. And while it's not as easy to identify what types of data this might work for, um, it is useful when we are able to find those relationships, or at least see which types of relationships exist to begin with. So with that, I'll leave you, and I hope you enjoyed it. Thank you.